Hello students, in the last video we have discussed about the three kinds of the turbidity meters. In this video other few we can discuss. The self-reading turbidity meter. The name itself it says that the self-reading turbidity meters directly it is going to give the reading of the turbidity or otherwise measurement of the turbidity. Then it is, what is the self-reading turbidity meter? A steel box or the galvanized steel box is available. In this there is a light is fixed here on the this is the lamp and this is a reflecting glass, and here this is a hole of the light which passes through this hole onto the sample. It comes on, and then these two are the mirrors, and then when these two are the mirrors, this is the eye slit to watch, and then this is a movable portion which we can able to make. This is the standard, one slit is the standard, and this is the moving portion of the slit, and this is the turbidity, whatever the turbidity graduated scale directly which we can able to read from it. And then how it is going to work? It's going to be filled with the sample to which we have to find out the turbidity, and light is lit, and then from this light the reflected light is going to from the reflector is going to pass through it. We have to watch from this, and then it starts once again, as these are all the mirrors, the reflections are going to happen in this. When reflections are happening, we have to watch that there is a spot is going to be available here, unless until we have to watch and then move this portion, that whatever the spot available on this on the light reflections is going to disappear. Then we have to move until that spot disappears. Then we as soon as it stops disappearing, we have to stop the moving portion. Then watch the directly whatever the direction this is there, that particular portion is going to give the turbidity of the given sample. So directly we can read. The units of this is directly in the ppm it's going to give. Let us see the another turbidity meter, which is of hellige turbidity meter. Then here we are basically the sample we have to take the turbidity cell up to the mark whatever is given. Here we have to keep the sample. Here this is the old version, this is the new version of the digital type. We have to keep the sample, and then what we are supposed to do, like a turbidity cell up to the mark, whatever the mark is given we have to fill it, and then through the eye whatever it is there, from here we have to see if it's going to give directly here. And then the eyepiece, there are two fields are there. One field, here one knob is there, here one knob is there, here another knob is there. The same things are available here in the latest versions. Then what we have to, how the right one and left one has to be operated. Then let us see. Whatever the control field corresponds to the light transmitted through the light scattered from the suspension of the sample, how much it is going to scatter that, and then the intensity of that particular scattered light we are going to balance it, and then we will be taking the reading. The light intensity, whatever the control, we have to control the spot balanced, and the surrounding field whatever it is available over there with the help of the this right knob. And then the brightness control has to, brightness of the light has to be controlled from this left hand side, and the light is going to be balanced at the different level by rotating it from the lower value to the higher value, value, and the black spot at the center it is going to be disappear. Then just wherever just it disappears, we have to stop it. Then that is going to be we have to view from this here, and then here directly whatever the measurement is there, that is going to give the turbidity of that particular sample. Here it is going to transmit those things into the electrical and then pulses, and then it is going to be given like a digital conversions. Then let us see one more. It's of like a nephliometer. This is the nephliometer. This is also like as it is made with the Hatch company, then some people do call it as a Hatch laboratory turbidity meter. Even here also we are going to get the NTU nephlio turbidity units. the output is going to cold, and then here you can see that NTU, and then how it is going to work. Let us see the modern, it's a modern commercial type of this. Here we are going to measure the light intensity. That means the one sample we are going to take, keep here, and then some light we are going to make it incident, and we will be rotating the direction about the axis, and this is a sample. Then whatever the light comes from this, the intensity of this light we are going to measure. From that intensity we are going to give the what is the turbidity of the water sample, and then that means just we will be water will be available here in the in this container. In this container water is a sample is available, and the incident light beam is going to be this one, and then it starts rotating the field. This is the light intensity what we are giving through it, and at the perpendicular direction whatever to that the dispersion, that intensity of the light we are going to measure. Those basically for the standard for this the photometers we do use to achieve this to measure. The photometer measures the intensity of the light using the like a turbidity way. After some light is scattered right angles to that incident ray we are going to take, and then this particular thing whatever it is there we are going to use for the reference turbidity. We will be using the formazine polymer. Formazine because one standard suspension should be there, our sample should be there. Then by taking the two light intensities, then the difference of it we are going to take it as a nephlio turbidity units. Sometimes as we are using the formazine polymer, for then you can call it as the formazine turbidity units also. Then for this what is the the best qualities of this, why we have stopped here to some extent. It's going to give the accuracy up to plus or minus 2% of the full scale, and high sensitivity of this instrument is 0.5% of the full scale, and the calibration we are doing with the formazine. And standardization, whatever the standardization we are going to do it for the sample whatever it is required. 30 ml of 0.2 and 10 ml of 10 ml of water for 10 to 100 ppm to the how to prepare the margin stock. Then we are going to take the 5 grams of the reagent or the grade of the drazine sulfonate. 5 grams of the reagent, the grade of a drazine sulfate. 400 ml we have to dilute in the distilled water, and we have to dissolve 500 grams of the pure hexamethane tetramine. 400 ml of distilled water, and add these two solutions we have to make up to the 1 liter of the volumetric flask and dilute it, and allow the solutions to stand for the 48 hours at 20 degrees centigrade, and then we can able to test these things, and it is going to stay for the 1 to 2 weeks. Meanwhile up to 1 to 2 weeks it is going to have the equal number of the size, shape particles, and it is going to be the stability is going to be very good. Then what are the requirements? 5 grams of the to prepare the stock we need 5 grams of the reagent grade by drazine sulfate. We have to add in the 400 ml, and 500 grams of the pure hexamethylene tetramine. 400 ml distilled water we have to add, and then we have to make up to the 1 liter volumetric flask. We have to dilute it, and we have to maintain this solution for 48 hours at 20 degrees centigrade, and develop the turbidity precipitate completely it is going to give. Then that we are supposed to make use as a standard solution, and the calibration we can make even this calibration it's going to give NTUs. Thank you. If you are having any doubts, let us see in the class, or otherwise you can post a comment too. Thank you. See you in the next video.